Hello, my name is Abdullah Murad. I'm from 7th grade, and my project title is Can You See It? Examining ascorbic acid retention in foods after 1 hour oxidation using redox titration. Vitamin C has many health benefits. It helps improve our immune system and helps our blood pressure. Vitamin C is an essential vitamin, meaning your body cannot produce it. It is water soluble and found in many fruits and vegetables, including strawberries, kiwi fruit, bell pepper, broccoli, kale, and spinach. Oxidation of vitamin C causes ascorbic acid to turn into dehydroascorbic acid, which contains less vitamin C. Ascorbic acid can be oxidized by reduction to oxygen metal ions at altered pH, light, or high temperature. This project examines whether vitamin C retention is affected by oxidation of oxygen in the air after a fruit was hypothesized. After a fruit is cut open and left out in the open air for an hour, the fruit used with oranges, kiwis, and strawberries. It was hypothesized that the oxidized fruit will not retain all the vitamin C. Redox titration with iodine solution starch indicated were used to determine the amount of ascorbic acid. So, redox titration determines the amount of ascorbic acid in the sample by using iodine as a titrant. To prepare the indicator starch solution, 1% of soluble starch, 1 gram was added to 100 milliliters of near boiling water. The flask was stirred vigorously to make sure the starch solution was dissolved. It was left to cool before using. This indicator will turn black as well as the end point the standardized vitamin solutions created by a pesticide molder were used to crush a 26 milligram tablet of vitamin C. After the tablet was crushed, 10 milliliters of decent water was added to the molder. The tablet was dissolved. It was added to a flask containing an additional 240 millimeters to have the concentration of 1 milligram of vitamin C, 1 millimeter of decent water. The iodine solution used was Rugose iodine. The standardized vitamin C solution titrate was prepared by placing 200 milliliters of the vitamin C solution into a 50 milliliter tube. Use 2 other 50 milliliter tubes and add 2 20 milliliters of the vitamin C solution into them to have 3 trials, one at a time. Use a pipette to add 10 drops of the first indicator into the tube. Swirl gently to mix the starch. Start the titration by using different pipettes to add the iodine solution 1 drop at a time. Gently swirl after each drop. Count how many drops it took to reach the endpoint titration. Record your findings. When ready to perform the experiment, cut oranges and juice them. Then use a cheesecloth to juice the pulp. Add 20 milliliters to a 50 milliliter tube. Use 2 other 50 milliliter tubes and add 20 milliliters of juice to each of them. So you have 3 trials. Use a pipette to add 10 drops of the indicator solution into each tube. Swirl the juice to mix the starch. Use a different pipette to titrate the iodine into each of the tubes one at a time until you reach the endpoint of titration. Gently swirl the tube after each drop of iodine. Count how many drops it took to reach the endpoint of titration. Record your findings. Repeat the steps above the kiwi strawberries with the exception of using a blender. So to oxidize it, to cut them into small pieces to maximize surface area. Every 1 drop of iodine is 0.05 millimeters. Calculate the amount of volume of iodine needed for each titration. The number of drops are multiplied by 0.05. Iodine 1 over vitamin C1 equals iodine 2 over vitamin C2. Amount of glucose iodine solution needed for vitamin C at the endpoint of titration for 20 milliliters of these two. For the control, the average was 40 millimeters. For juice oranges, 18.67 millimeters. Juice kiwis was 19.76 millimeters. Juice strawberries was 23.67 millimeters. This was without oxidization. With oxidization, control was 34.33%. Juiced oranges was 13.33%. Juiced kiwis was 12.33%. Juiced strawberries was 18.33%. Amount of Rugose iodine solution in millimeters needed to reach the endpoint of titration for 20 millimeters each. For the control, 2 millimeters. Average juice oranges, 0.93 millimeters. Average juice kiwis, 0.97 millimeters. Average juice strawberries, 1.18 millimeters. Average with oxidization, 1.72 for the control. Juiced oranges is 0.67. Juiced kiwi is 0.61 millimeters. Juiced strawberry is 0.92 millimeters. In grams, it would be for the control before oxidation, 20 milligrams. After oxidation is shown. Before oxidation is shown here. After it is shown here. Amount of vitamin C drops is shown here. Percent of vitamin C drops is shown here. The graph on the left clearly shows the amount of ascorbic acid was decreased to the fruit was left open. In conclusion, after the experiment was done, it was concluded that the three fruits for this experiment had lost their oxidation considerable amount. So this means my hypothesis was supported. I would like to thank my amazing points for supporting me and my awesome teacher for supervising me and creating my graph.